Okay, volume of a cuboid. Alright, so we've got your tank in the shape of a cuboid as a base measuring 42 by 25 and a height of 20. Calculate the volume of the tank. So quite simply, if you remember, the volume of a cuboid is just length times width times height. Okay, and you just got to times those dimensions together. So 42 times 25 times 20. So get your calculator, and it comes to 21,000. Now, centimeters cubed, of course, right? Because volume is three-dimensional. We've times three values together, haven't we? Three-dimensional, so a little 3 there. Part B says water is poured into the tank. Okay, so water is actually poured into this tank. The volume of the water is 8,400. Calculate the depth of the water in the tank. Now, what I tend to do when I read something like this, I go back to my diagram and I try to imagine what's gone on here. So you've got water that's gone in here, okay? And you can see that actually the water hasn't filled the tank, if you think about it, okay? The water hasn't filled it because it says the volume is only 8,400, and we've just worked out the volume of the tank to be 21,000. Okay, so by no means is it being filled up. So we're interested in the depth of the water in the tank. In other words, we're interested in this sort of, I mean, I would call it H, I would. I'd be thinking of it in terms of its height, the water, okay? It's certainly not going to be 20, because the water hasn't filled that tank, so it's not all the way up, okay? What's good though is we actually do know the volume of this water, and if you think about it, this water has filled this here, is in the shape of a cuboid still, so we can still use this formula, okay? And if you think about it, we would times the length and width, wouldn't we? We do 42 times 25, and we'd also then times it by the height to get our volume. And we don't know what the height is, so I'm just going to call it h. I'm going to say times by h. But the good thing is we actually do know what the volume of the water is. We know this is equal to 8,400. Okay, so what I'm going to do next, right? This is like a sort of working backwards type problem, okay? Whereas they give you the volume and you're sort of trying to work out one of the dimensions, in this case the depth of the water, which we've called h. So what I'm going to do, I'm just going to work this out here, 42 times 25, okay? I'm just going to work that out, and it comes to 1,050 times h. And then you've got yourself an equation here, and you've just got to think, well, I'm timesing here by 1,050 to get h on its own. I've just got to divide, haven't I? You've got to take it over to the other side, sometimes in, take it over and divide. So I use my calculator. Comes out as 8 centimeters. Okay? So we worked up the height there by working backwards using the formula for volume of a cuboid. Next one, there's no diagram here, but it says the volume of a square-based cuboid is 180 centimeter cubed. The height of the cuboid is 5. Find the length of the sides of the base of the cuboid. A sketch will help you, okay? And what's good is that it's a square-based cuboid. So in terms of its base, it's going to look something like that, right? And of course then we've got its height. So hopefully that makes sense the way I've drawn that there. The base is a square. The height we're told is 5. Now the base is a square, so we don't know how long it is. Maybe we call it L. We don't know how long it is, but the good thing is that's also L as well, isn't it? Because it's a square. Okay, so the length and width is the same. Now, when I calculate when I'm working with volume, okay, we know the formula for cuboid. We've just seen that, and also we know the answer to this one, don't we? So we can do the same thing as last time. Okay, length times the height there. So L times 5 equals 180. Now L times L is L squared. Okay, so I've just simplified that because L times L is L squared. And then you've got to think, well, I'm timesing L squared by 5. Okay, well, I can take that over the other side, can't I? Of course, because I'm times n, take it over and divide. And I'm getting close to getting L on its own. Now when I work out then 180 divided by 5, that comes out to be 36. And you've got to think then, I want L, this is L squared. So if I take the square over the other side, yeah, you can think of taking the square over the other side. And of course, when we take it over the other side, we do the opposite. So take the square over, and we end up square rooting. If you square root 36, you get 6 centimeters. And there's our answer. There's our length of the sides of the base of the cuboid.